Okay, let's talk about another interesting theorem. Okay, it is Abel's theorem. Okay, so well, like let me try to read the statement of this theorem first. Okay, it is second order linear differential equation. Okay, then they state like this theorem states like how we can find the Wronskian without y1 and y2, which is equal to c times e to the minus integral pt dt, right? And you can find Wronskian without y1 and y2. In the previous problem, I gave you like y1 and y2, then we calculate the Wronskian, right? And then, but like this theorem, and even you do not know about y1 and y2, and we can calculate the Wronskian, okay? And like, you know, most of you will say, hey, JD, then why do you have to learn about this one? Think about it. Sometimes even you do not know or you cannot find the solution of like given differential equation, but we can check the existence of your fundamental set of solution, right? So like, you know, if we just like can find the Wronskian by this way, and then we can figure out like, you know, your Wronskian is not equal to 0 in the some given interval, okay? Then we can say, even we do not know what that is, but we can say there is two particular solutions and they will form the fundamental set of solution, okay? This is the meaning of Abel's theorem, okay? Let me give you one example to find the Wronskian without y1 and y2, okay? Here we go. Look at number 10. So like, you know, given differential equation is definitely second order linear differential equation, right? Look at cosine t and sine t and minus t. All those are function of t. It is linear, okay? So to apply the Abel's theorem, we have to make the coefficient free for the leading term, which means we have to divide by cosine t everywhere at the first time, okay? So we'll divide by cosine t on both sides everywhere and to make it standard form, okay? So here we go. Then in a standard form, my differential equation can be written by y double prime plus sine t over cosine t y prime minus t over cosine t y is equal to 0. Okay, and let me apply the Abel's theorem. By Abel's theorem, what happened? My Wronskian of y1 and y2 can be written by c times e to the minus integral pt dt, right? My p is sine t over cosine t dt. What is the integral of sine over cosine? Definitely you can use the u sub, right? If you decide cosine t as u and du is minus sine dt, right? And you can you find minus sine t in your integral? Minus outside, but you can do, okay? So like by the u sub, this can be written by c times e to the ln of absolute value of cosine t, right? And you don't have to worry about constant, okay? It is just like now included in the like c improper exponential function now, okay? So, okay. And then like one of the property of like, you know, exponential function with log exponent, right? And then cosine t can come out, then we can write this one as constant c times cosine t. Is okay? This is your Wronskian, okay? And okay, this is a way to find Wronskian, okay? This problem asks you to find Wronskian, okay? Then maybe we can stop here, okay? And in some interval, we can say your Wronskian is not equal to 0, but like, you know, we will talk about that one in next problem, okay? Here we go. And what about this one? Okay, if the differential equation is given like this way, that is definitely second order linear differential equation, okay? So we're gonna try to, we are not gonna try to find the fundamental theorem of solution, but like, you know, the given Wronskian, from the given Wronskian, and we're gonna try to find Wronskian of 5. Is that okay? So let me show it to you, okay? It's very easy, okay? So first of all, we have to make it as standard form, which means we're gonna divide by 5 t on both sides, okay? And the differential equations in a standard form will be y double prime plus 2 over t y prime plus t canceled out. It's a t, y is equal to 0. Okay, so now my pt is 2 over t, right? And then by the Abel's theorem, my Wronskian of y1 and y2 is equal to constant c times e to the minus integral pt dt, right? Pt is 2 over t dt. Are you with me so far? And then, like, antiderivative of 2t, right? It is easy, right? C times e to the minus 2 ln t, which is equal to C times e to the ln t to the minus 2, right? And then that is equal to C times t to the minus 2, and we can write C over t squared. This is my Wronskian, okay? And like in the problem, they said Wronskian of 1, which means we can plug in 1 into t, that is equal to 2, right? Which means we can decide constant C for this Wronskian, right? Here we go. Since the Wronskian of 1 is equal to, and plug in 1 in there, then C over 1 squared must be equal to, then I can decide my C as 2, right? Let me update. Then my Wronskian of y1 and y2 is equal to 2 over t squared. So the Wronskian of 5 can be calculated like this way. It's very simple thing, right? 2 over 25. This is the way to find the value of Wronskian, okay?